today is about adoption of automated vehicles, and I will share with you some highlights of this project, which involves 10 partners. It goes on for 45 months, ending in February next year, and is about 3 million in budget. We aim at doing multidisciplinary work and to look at HMIs as well as enhancement of ADAS, so that we can see if we can increase the adoption of automated vehicles, and also have means to have validation protocols for possible measures. One of the things we have done is a population survey. It was undertaken online with about 1,000 respondents from each of the 7 brave countries. We looked at both the people who were outside the vehicles, vulnerable road users, and drivers of conventional cars, and asked about acceptance and trust-related issues regarding level 3 automated vehicles. Among the results, we found that in general there is a quite positive attitude, but it is not so widespread. There is some lack of trust, however, and some are skeptic to use the vehicles by themselves if they were automated vehicles. We find differences between distinct road user groups and also between countries where people live. Among the learnings, we looked at, for example, pedestrian crossings, and there we found that more than half of the respondents would actually trust human car drivers more than automated vehicle. And we also found that, for example, riders of powered two-wheelers and bikes, they were trusting automated vehicles more than drivers and pedestrians. It is also important to indicate the automation status to the different road user groups. We will look further into pedestrians as we move along in this presentation. So what do we do about acceptance and trust? Well, we looked at HMI, and we used simulator studies to do that. We had focus groups and we had concept development, and we found that the clean and simple user interfaces are essential, and it is very good to indicate to have transparency of the systems, both to occupants of vehicles but also to other road users. The HMI should preferably adapt depending on the driver status and the driver behavior. And if it is a critical situation, the driver should be supported to regain their attention to the relevant risk factors. We also looked, as I said, into pedestrians, and for example, we looked into would there be any benefit from an acceptance point of view when it comes to anticipating pedestrians and predicting what they want to do. And we found that the driver's trust would increase, and the driver would actually have a better opportunity to react to pedestrians that may certainly suddenly show up. It would also give more room for the driver to determine if they would engage in something other than driving or not, which is sort of the point of a level 3 vehicle sometimes. Also, we found that prediction systems, they increase the time for the planning of motion of the vehicle, and thereby the deceleration could be smoother, which would increase safety and comfort, and in turn then affect the acceptance favorably. We spoke about the tailored or adapted messaging, and in order to do this, we developed a features detection algorithm so that we could study driver state and behavior and detect those and see how we could generate the most suitable alert of the driver. And the result was a scheme along the lines that you can see here. I won't go into the details though. Also, tailoring messages, you could think about external HMIs and those outside the vehicles. So we looked at external HMIs and vehicle deceleration and used the virtual reality walking simulator to study the pedestrian's subjective perception and whether they would be comfortable to cross or not, depending on what they saw the automated vehicle do. We looked at vehicles yielding and vehicles not yielding and found that in order to be most effective, vehicles should decelerate and send an external HMI message at the same time. If vehicles were not yielding, it would be better that they did not decelerate at all and kept a constant speed. And in both yielding and non-yielding cases, a late deceleration together with no external HMI message was the worst case. New prediction algorithms have been developed in the project. We're again looking into prediction, and we looked at vehicles, how to predict the intention and trajectory of surrounding vehicles. This AI-based system proved to be 1 second faster than current systems in detecting lane changes and half a second faster than human drivers. Also, in the prediction arena, we looked into if VRU intentions and paths could be predicted and developed a system that could do that. It was based on CNN and RNN. And in order to do that, data set was created. It's called Prevention, and it contains vehicle and VRU data, and it is an open data set. It would, of course, be good if you make a prediction system and put it on your vehicle that it can be honored and evaluated in some kind of testing method. So we looked through all the Euro NCAP and regulatory test protocols that could be relevant for the situations and found that whereas some situations, some use cases could be covered, there were others where we found that we could propose enhancements so that they really enable that anticipation is assessed. One of the recommendations is to have an articulated pedestrian dummies. We have also developed 2 new scenarios that can be used to identify pedestrians and anticipation maneuvers. And then the smooth driving I mentioned earlier, it is currently not assessed. It is sort of registered, but we also developed some proposals for criteria that could be used here, because that seemed to be associated also with acceptance. What do we do next? We wrap up the project. There's a final demo and a final event to be done together with all the final research. We are discussing with working groups of Euro NCAP and regulations that deal with the regulations as well, our findings and proposals. And we have, of course, identified future research needs. We would like to couple acceptance more with accidentology and technical solutions, have a whole chain of events there, and to work more on external HMIs. How could that be conveyed, messages be conveyed in the best way? And of course, there is much more to do on acceptance, both for level 3 and also when we go on to level 4. And we would like to invite you to join our final event, which takes place in February, and of course it will be done online. Welcome and thank you.